Somewhere in the North Sea, a structure heavier than 3 Eiffel Towers is standing on steel legs driven into the seabed. In a few minutes, it will not be standing there anymore. No crane will touch it. Instead, a ship is going to sink itself, slide underneath, and then rise, tearing the entire platform off its legs in a single movement. This is how that is possible. The platform is called Brent Charlie. It weighs 31,000 tons. It has been sitting in the same patch of water off the coast of Scotland since 1978. And for most of that time, it was one of the most productive oil platforms in Europe. But oil fields run dry, and when they do, somebody has to take the platform away. Not switch it off, not abandon it. Physically remove it, haul it back to shore, and cut it into pieces small enough to melt down. For decades, that job was done the only way anyone knew how. You sent crews out to the platform, and they cut it apart where it stood. Module by module, beam by beam, a floating crane vessel would sit alongside, lifting off whatever piece had just been separated, and the whole process could take 2 or 3 years. Every one of those days was a day when men were working with cutting torches, hundreds of feet above cold water, on a structure that was slowly being taken apart underneath them. It was expensive, it was slow, and it was one of the most dangerous jobs in the offshore industry. A Dutch engineer named Edward Hirema looked at that problem in 1987 and asked a question that sounds almost childish. Why are we taking the platform apart at sea? Why not just pick the whole thing up and carry it home in one piece? The answer, at the time, was simple. Nothing on Earth could lift that much. The largest floating cranes in the world could manage a few thousand tons. A platform topside, the part that sits above the water with the drilling equipment and the processing plant and the living quarters for the crew, could weigh 20,000 tons or more. There was no crane. There was no ship. There was no machine of any kind capable of picking up something that heavy and holding it steady on an ocean that never stops moving. So Hirema stopped thinking about cranes. Here is the insight that made everything else possible. A crane lifts by pulling upward against gravity, and to do that it needs a structure strong enough to carry the entire load through a single point at the top. That structure gets heavier and more expensive faster than the load it can lift. Double the weight you want to lift, and you more than double the size of the crane. At around 20,000 tons, the mathematics simply stops working. The crane becomes impossible to build. But there is another force that lifts things, and it does not care how heavy they are. Buoyancy. A ship floats because the water it pushes out of the way weighs the same as the ship itself. That is the whole principle. And it means that if you make a ship lighter, by pumping water out of it, the ship rises. It rises with enormous force because the ocean underneath it is pushing up on the entire surface of the hull at once. There is no single point of stress. There is no boom, no cable, no hook. The lifting force is spread across thousands of square meters of steel. So the idea became this: do not build a bigger crane. Build a ship that can lower itself into the water, get underneath the platform, and then float back up while carrying it. That is what pioneering spirit is. The vessel is 382 meters long and 124 meters wide. To put that in some kind of proportion, it is longer than the Empire State Building is tall, and wide enough that you could lay a football pitch across its deck sideways. Its gross tonnage is 403,000, which makes it the largest ship in the world by that measurement. Fully loaded, it displaces around 1 million tons of water. There has never been a vehicle of any kind, on land, at sea, or in the air, that weighs as much as this one. But the number that actually matters is not the length or the tonnage. It is the shape. Look at Pioneering Spirit from above and you will see something that does not look like a ship at all. The bow is not pointed. It is split. There is an enormous rectangular notch cut into the front of the vessel, 122 meters deep and 59 meters wide, running back into the hull like the open jaws of something. Two separate hulls run down either side of that slot, joined together behind it. The ship is essentially a catamaran with a canyon carved into its face. That slot is the entire point. It is shaped that way so the vessel can drive around a platform surrounding it on three sides and put the platform's legs inside its own body. Across the mouth of that slot sit 8 horizontal lifting beams. They are massive steel arms that can extend out from each hull and reach across the gap. When they are retracted, the slot is open and the ship can move freely. When they are extended, they form a set of steel shelves stretching underneath whatever is sitting in that gap. Now, put those two ideas together, and the whole operation becomes clear. The ship arrives at the platform and turns around because it approaches stern first and then rotates, positioning itself so the open slot faces the structure. Then it begins to take on ballast water. Thousands of tons of seawater are pumped into tanks inside the twin hulls, and Pioneering Spirit begins to sink, not accidentally, deliberately, under complete control, sinking itself lower and lower into the water until the lifting beams pass beneath the underside of the platform topside. The ship then moves forward, sliding the slot around the platform's legs. The lifting beams extend. They reach in under the topside, positioning themselves under specific reinforced points on the structure's base, points that engineers identified and prepared months earlier. And then the pumps reverse. Water starts coming out of the ballast tanks. The ship gets lighter. Buoyancy takes over. Pioneering Spirit begins to rise, and as it rises, the lifting beams press up against the underside of 31,000 tons of steel. For a moment, everything is held in tension. The platform still bolted and welded to the legs that have carried it for decades. The entire ocean pushing up underneath the vessel that is trying to take it away. Then the connection breaks. The topside separates from its legs, and in a matter of seconds, it is no longer part of the seabed. It is cargo. It is sitting on a ship. That last part is worth sitting with for a moment because the speed is not a detail. It is the whole design. The most dangerous part of any offshore lift is the instant of separation, when the load is neither attached to the structure nor fully carried by the vessel. Traditional methods stretch that moment out. Pioneering Spirit compresses it into a few seconds, because the faster the transfer happens, the less time there is for anything to go wrong. But there is a problem in this design that is much harder than the lifting itself, and it is the reason the concept sat on paper for more than 20 years. The platform does not move. It is welded to legs that are driven deep into the seabed, and it is as motionless as a building. The ship moves. It is floating in the North Sea, and the North Sea is one of the roughest bodies of water on the planet. Even on a calm day, a swell is rolling through. The vessel pitches. It rolls. It heaves up and down. So at the instant those lifting beams make contact, you have a completely rigid object and a moving object about to touch each other, with tens of thousands of tons involved. If the ship heaves upward at the wrong moment, the beams slam into the platform with a force that could crush both. If it drops at the wrong moment, the load is released and dropped from a height. Either outcome is a catastrophe. The solution is a system that most people never hear about, and it is the real engineering achievement here. Every one of those lifting beams sits on a set of hydraulic cylinders that actively compensate for the ship's movement. Sensors read the vessel's motion continuously. The cylinders extend and retract to cancel that motion out, so that the tips of the beams stay effectively still relative to the platform, even while the hull underneath them is rising and falling with the sea. In practice, it means the ship is moving and the beams are not. The vessel absorbs the ocean and the load never feels it. And even with that system working perfectly, the operation only proceeds inside a very narrow window. Every lift is planned against a forecast, and the sea state has to fall below a specific limit before the vessel is allowed to begin. Crews have waited weeks in the North Sea for a window to open. There is a point in the sequence, once the beams are extended and the ship has committed to the approach, where backing out safely becomes far more difficult than continuing, which is why the decision to start is made hours in advance by people looking at wave data and not by anyone standing on deck watching the platform get closer. There are up to 571 people living aboard during a campaign, in two-berth cabins, and most of them have nothing to do with the lift itself. They are running the power plant, the ballast systems, the welding stations, the control rooms, and the accommodation for a vessel that functions less like a ship than like a floating industrial town that occasionally performs the heaviest single act of lifting on the planet. The same principle governs how the ship holds position at all. Pioneering Spirit has no anchors deployed during a lift. It stays where it is using 12 azimuth thrusters, propulsion units that can rotate in any direction, fed by 8 enormous 20-cylinder diesel generators, producing 95 megawatts of installed power. That is roughly enough electricity to supply a small city, and during a lift, almost all of it is being spent standing still. Satellite positioning and reference sensors feed a control system that adjusts thrust hundreds of times per minute, holding a 1 million-ton vessel within centimeters of where it needs to be, while it slides itself around a platform it must not touch. The construction of the vessel took a long time and a great deal of money. Allseas, Hirama's company, awarded the building contract to a shipyard in South Korea in June of 2010. The price was 2.6 billion euros. The ship left the yard in November of 2014 and arrived in Rotterdam in January of 2015 for the rest of its outfitting. It also arrived with a different name and then lost it. The vessel was originally called Peter Schelte, after Hirama's father, who had been a genuine pioneer of the offshore industry. But Peter Schelte Hirama had also served in the Waffen-SS during the Second World War, and when the ship became public knowledge, the objections were immediate and severe. Members of the British Parliament raised it. Trade unions raised it. In February of 2015, Allseas renamed the vessel Pioneering Spirit. Its first real test came in August of 2016 in Norwegian waters. The target was a structure called the Wyme Mobile Offshore Production Unit, owned by Repsol. It weighed 13,500 tons. By the standards of what the ship was designed to do, this was a modest load, barely a quarter of its rated capacity. But nobody had ever attempted the maneuver before, and there was no way to fully rehearse it. It worked. The topside came off in one piece and went back to shore. The following April, the ship went after something considerably larger. Brent Delta was one of 4 platforms in the Brent field, the field that gave its name to the global oil price benchmark that traders still quote today. Its topside weighed 24,200 tons. Shell had spent years preparing the structure for removal, reinforcing the lift points, and stripping out everything that did not need to make the journey. Pioneering Spirit took the entire topside off in a single lift, then carried it across the North Sea to Hartlepool in the northeast of England, where it was pushed onto a barge and then onto land to be broken up. Standing on the shore watching that thing arrive, it did not look like a piece of industrial equipment. It looked like a small town riding on a ship. The lift set a world record. It did not hold it for long because the same ship kept breaking it. In June of 2019, Pioneering Spirit removed the Brent Bravo topsides at 25,000 tons. In that same month, it also performed what was, for it, an unusually delicate job, lifting the Valhall quarters platform, which weighed only 3,800 tons. That is the lightest lift the ship has ever done, and it is a reminder that precision matters as much as brute capacity. A machine built to handle 30,000 tons still has to be gentle enough to pick up something a tenth of that size without damaging it. Then, on the 9th of July, 2024, the ship went back to the Brent field one last time for Brent Charlie. 31,000 tons, the heaviest offshore lift ever performed, by any method, by anyone. The topside came off its legs, went aboard, and was carried to Hartlepool, where more than 97% of the material was recycled. It closed out a decommissioning program that had run for over a decade and covered all 4 Brent platforms. But the topside is only half of a platform. Underneath it, holding it out of the water, is the jacket, the steel lattice tower standing on the seabed. And once the topside is gone, somebody has to remove that too. So in 2021, Allseas bolted a second machine onto the back of the ship. The jacket lift system works on a completely different principle from the bow. 2 connected steel beams, each 170 meters long and together weighing 6,500 tons, extend from the stern of the vessel. They can be raised and tilted using a set of skid tracks fitted with push and pull mechanisms, which means the beams can be lowered down toward the water, gripped around a jacket that has been cut free at its base, and then pulled back up and tilted horizontally so the whole tower lies flat across the ship's stern for the trip home. That system can handle jackets weighing up to 20,000 tons, which means Pioneering Spirit can now take an entire offshore platform, the part above the water and the part below it, and remove all of it without a single cutting torch going anywhere near a working structure. It would be easy to think of this vessel as a demolition machine, but that is only part of what it does. And arguably not the more impressive part. The same system that rips a platform off its legs can also put one on. Between 2018 and 2019, Pioneering Spirit installed 3 topsides on the Johan Sverdrup field in the Norwegian North Sea, including one weighing 26,000 tons. Installation is harder than removal. When you take a platform off, you only have to break the connection. When you put one on, you have to land 26,000 tons onto a set of legs and align the mating points within centimeters on an ocean that is moving the entire time, and you only get one attempt. There is no lifting it back up and trying again. The traditional alternative was to build the topside in modules, ship them out separately, and assemble them offshore over the course of a year or more. Single lift installation compresses that into a day. The modules are built and tested on shore in a yard where work is cheaper, safer, and faster. And then the finished platform goes out in one piece. And even that is not the ship's only job. Pioneering Spirit is also the largest pipe-lay vessel in the world. It carries a stinger, the curved ramp that guides pipe off the back of the ship and down toward the seabed, that weighs 4,200 tons and measures 150 meters by 65. Its tensioning system can hold 2,000 tons of pipe weight, roughly double any competing vessel, and it can lay pipeline in water more than 4,000 meters deep. 6 welding stations and a double-joint factory run along the deck, which means lengths of pipe are welded together on board continuously as the ship moves forward. Between May of 2017 and November of 2018, the vessel laid the offshore section of the Turkish Stream pipeline across the Black Sea. Two parallel lines, each running 930 kilometers, through some of the deepest water any pipeline has ever crossed. So one ship removes platforms, installs platforms, and lays deep water pipeline, and it holds the world record in all three categories. There is a reason this machine exists now and not 30 years ago, and it has less to do with engineering than with timing. The North Sea filled up with platforms in the 1970s and 80s, hundreds of them built during an oil boom and built to last. Most were designed with a working life of 25 to 30 years, which means that starting in the 2000s and accelerating ever since, a very large number of very large structures have been reaching the end of their lives at roughly the same moment. Somebody has to take them all away, and the companies that own them are legally required to do it. Decommissioning the North Sea is a bill measured in tens of billions. When that is the scale of the problem, a 2.6 billion euro ship stops looking extravagant. It looks like arithmetic. If single lift removal takes a job that used to require 2 years of offshore work and turns it into a few days, the savings across hundreds of platforms are enormous, and the safety improvement is not really measurable in money at all. Every module that does not have to be cut apart by hand, hundreds of feet above the North Sea, is a set of risks that simply never happens. All Seas did try to go further. In 2018, the company announced a successor vessel called Amazing Grace, larger still, and scheduled for delivery in 2022. In July of 2020, the project was suspended indefinitely. Whether it ever gets built is an open question, and it may depend on how quickly the offshore world moves on to other things. Because there is one more thing worth saying about all of this. Pioneering Spirit was designed and built by an oil industry for an oil industry at a moment when that industry was at its peak. But the ship does not actually care what it is carrying. A machine that can install a 26,000-ton structure onto legs in the open ocean in a single day with centimeter precision is a machine that is well suited to putting up other things in deep water. And the offshore wind industry is now building foundations and platforms at exactly the kind of scale that this vessel was made for, which leaves a strange kind of symmetry. The largest machine ever built to take apart the infrastructure of one era may end up building the infrastructure of the next one. But the image that stays is the one from the beginning. A ship the size of a district, filling its own hull with water on purpose, sinking down into the North Sea until it is beneath the thing it came for. Steel arms sliding out into the dark under 31,000 tons, and then the pumps reversing, and the whole ocean pushing up underneath 1 million tons of hull, and a structure that stood in the same place for 46 years, coming free of the seabed. Not slowly, not piece by piece, but all at once, in a handful of seconds, and then floating away, not lifted, simply taken.